Oh, hello there. Welcome to another session of Electronically Assisted Astronomy with an 8-inch Schmidt-Cassegrain telescope. My name is Pete. We're observing from the Isle of Wight. It is the 9th of December and it's quite windy outside. Yeah, it's windy quite a lot. Let's see how I reverse that. I'm not sure this is going to work, okay? But the reason I put it out there is that it is kind of clear, but we might be dodging showers. But haven't really been able to observe much, and I think that's the same for a lot of people down this way. Clouds, rain, the world gets in the way, but mainly clouds and rain get in the way. So we're suffering a bit. Had a really good kind of run all the way up to the middle of October, and then after that, disaster. Couldn't get out. So we're going to go from the beginning and then we'll cut this video together as we see fit. So actually what we've got up on the screen right now is we've got the sky running. It's looking down into our western horizon. There's a tree over here. Cygnus, the summer constellations are sinking away into the west. And the wind is coming from, well, it's coming from everywhere. It's swirling a little bit, but it's quite blustery. Over here we've got the latest version of SharpCap as released on Monday. We've got CPC up here. This is the 2.5.3 beta 1. I think there's a beta 2, but none of the features are kind of interest to me. But so I've kept beta 1. And we've got a new control panel over here. It's been kind of revamped. It's a bit more colourful. It's got a few more features into it. And it also supports SAMP, which we might talk about in a minute. Did I shout SAMP there? Sorry about that. So let's just get set up. So we've got CPWI set up. We're going to do a manual alignment. So I'm going to begin the alignment. And I'm connected. Let's go to fine mode. Oh, before I do that, let me start my script over in SharpCap. So this is the script that runs. Now, SharpCap has no way of controlling it externally, but it does have a very powerful scripting language, Python. And so actually it's quite straightforward to write something to do it for you. And what I'm using is MQTT because I have an MQTT server. I was going to use the one I use for my Internet of Things, but in fact I just set up a Mosquito server, free of charge obviously, just download it, very good. And I've just connected now and subscribed to 2 channels, one that tells it what to do, a command channel and an output channel. My EA control panel connects to the MQTT server as well. And we'll go, in fact what we'll do, we'll have to start that again because I hadn't started that up before. Let's have a little look and start that again. All the software. In fact, if I look at my log, oh, it's not going to tell me anything. Oh, there you go. It only does it when I do my first command. I should have known that considering I wrote it, didn't I? So there we go. So I've sent a command. So it connected again to the same MQTT server running down on the laptop, which is outside. And I issued the find command. And as you see, it's gone into a find command. Now, I'm not using the dew shield tonight, mainly because it's blowing quite hard. So I don't think there's going to be any dew tonight. But it was also to reduce the cross area of the scope. Oh wow, I could steer the wind then. I don't think this is going to work very well. But we'll give it a go. This is the whole point. Let's just give it a go. So what we're going to do first of all, then we are ready to begin. So I click on CPWI ready. It thinks we're aligned north, which we are, and we're level. As level as always. Let's come out a bit and choose a target. Mine is quite low. I wonder if we could choose Deneb. Yeah. Let's go to Deneb. And off we go, which is good. So we're going to be using SharpSolve as we do now, because it's fast and it works. Let's see if it carries on doing that. If it doesn't, we can use Astap, or we can use All Sky Plate Solver. You can use Plate Solve. I haven't. I think Plate Solve will become the new standard for this. We've got stars. Oh wow, we've got stars. Oh, there it goes. Come back. So we're not quite focused yet. So let's just, well, you press the little blue button up here, blue plug. It connects us all up to our telescope and also to the focuser. Well, we're moving around all over the place. So let's just click on the little, it's kind of like GPS position. Oh, look how fast it finds it. That's just so good. Robin is fantastic. There it is. There's dinner. And still moving around a bit. Let's pull it across. Say it's good enough. It's centered. Let's head over to. There's that. Where's Alto's gone far too far down into the ground. Down into the ground, down into the horizon. Let's try Enif, which is in Pegasus. We'll go to Enif. Oh, shall we connect our mount here? Oh, tell you what we need to do there first then. Let's start up the ASCOM remote server. So, there's the ASCOM remote server. There's NF over there. We're started and we're connected. And now we have the sky connected to us as well. Too lazy to put it back into the center, so I'll use PlateSolve again. SharpSolve. I'm not going to call it PlateSolve, it's SharpSolve from now on. Dump. There we go. I don't know why I'm giving you sound effects. Still a bit low, so we'll pull it a bit more. We'll say it's centered on that. Where are we going to go now? Oh, maybe I'm going to go up to Alpharats actually. Let's go up high. So let's go to the top star of the square of Pegasus. I remember doing this when I was outside, and you have to slew the telescope, so the viewfinder, use use the finder scope to get the star in and then adjust it, and nowadays, look, just sit here and go, oh, I'm a bit lazy to move it from there to there, so I just click this button in SharpCap, and too few stars the first time. Oh, we've got a failure. See, that's because let's try again. Okay. What am I doing? Let's do a second. And let's button. Yay. Oh, there's a new feature. Look, it's 1285.3. I thought it was 1281. So there's a new feature that in the front it tells you the focal length, which is nice, of your scope. I thought it was 1281 according to astrometry.net, and that says 1285. Ooh, interesting to look into. It's getting much more closer. It's getting much more close. It's getting much closer. I've got to work on my English tonight. Sorry about that. It's just the excitement of actually seeing stars. Are we not going to move at all? Telescope's upset. Is the wind blowing against it or something? I really can't be bothered with, say, centered. There we go. Jupiter. Not keen on aligning on Jupiter. Let's align somewhere else. What's this up here? Mothala? Is that what it's called? Mothala. Yes, in Triangulum. Let's go there, but let's do something. Yeah, I'm going to change my approach. I just find it's better. Triangulum, we need that one right there. I just find it better when I'm east of the meridian. If I approach from a different angle in declination, yeah, then it stabilizes a lot quicker. Here we are. So that's good. I'm going to come down a little bit. Okay, let's go across a bit. I'm not sure 100% we need to do this, but we will. Just for peace of mind, and also because I find it quite relaxing just lining stars up. I don't know why. I'm going to switch my rate down to 4 times sidereal and go up. You see, as soon as I do that, there's backlash, isn't there? And the backlash compensation, I can only stipulate one figure, and I have a feeling I need to be able to stipulate a different figure for each direction on this scope. I think it's maybe worn down a bit. I think we'll say that's good. We'll center it. We go to one more just because why not? It's fun, isn't it? We could just go down to, it's not very far. Let's go to Attic. Attic. Where's that? That one's, oh, there it is. Right there. Let's go a little bit towards Perseus. Ooh, yeah. Yeah, that's nice, isn't it? Those points have definitely added up. Yeah, we're centered and we're finished. And we'll exit that. Alignment, view the pointing model. What does it say? Says sensitivity of 10. I think that's good. I think a low number's good. Yeah, I think that's good. We'll stay with that's good. Oh, there's a satellite. Let's get rid of our magnifier as well and put that. Oh, it's the magnifier on the laptop we're using. I wondered why it was a little bit funny. There we go. We'll put that one over there for now. Now I'm just going to check over here because I've got the weather radar up and there's nothing on the weather radar, but let me just check that that's up to 10 past 7, so time now is 20 past 7. So we're 10 minutes behind. Let's find, while we're over this area, oh wow. So these are all the asteroids. Tons of the little devils. Everywhere. Solar system objects. Let's get rid of the large database. That's good. I've also got the Herschel loaded as well. But for now we'll leave that as it is. Now we're at Attic. All I want's a cluster. What was wrong with this cluster? NGC 1342. Oh, I haven't got Astro Planner up. Now this is beta 26, but it's not quite. It's a pre-beta 26 because Paul kindly did some added in a couple of features. One of them is that we can use SAMP from Astroplan scripting, which was really good. NGC 1342. Now I'm working on something within here to just so I can just take and just add in as I want. But we'll just take that down. So NGC 1342. Let's sync the planetarium. And because the sky still doesn't support ALTAS field of view indicators, I have to support it for them. Seems like a nice cluster, doesn't it? Let's blah, 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 blah. Let's connect telescope up. Put the little thing down here so we know where we are in the world. And pin it. Shall we slew or shall we target? We're going to config, we're going to slew. Yeah.
Telescope slewing 7 degrees.
Not very far. This looks a nice cluster. The reason I want to go to NGC 1342. Oh yeah, there we go.
Slewing completed.
Now, I think this is going to cause nothing but problems if I try and do a automatic focus on this, but being a... we're at... yeah, and let's come in negative. So let's see then if we've got a problem with the wind vibrating. We have a problem if you delete a point when it's trying to calculate it. Because I have to say that these points don't look bad. They all seem to be nicely graphing up. It might be the well enough points to the right hand side. I mean, we are a little bit funny here. Oh, there's a point. Oh, it says it's done. Okay. We'll give it the benefit of the doubt. Yeah, okay. That was intriguing as well. Okay. Astro Planner. We're at 1342. We've never observed 1342, so we might as well observe 1342. Let's observe it. Let's kind of blow some cobwebs away as well so that we can let's align it. I have a feeling we might need our FWHM filter tonight to get us anything. Worthy of a good shot. Industry 3042 is an open cluster. Magnitude 6.7. So we've got sigma clipping on, which works with dithering hand in hand, and it usually gets rid of most of this. I don't use the satellite tracking bit. I should do, I've said it before, but I haven't set it up, and I usually found that the dithering and the sigma clipping did the job. Let's go to enhancements, and we put the bilateral filter on. And that diminishes some of the noise. Let's try the colour. And let's try it off. Yeah, so the colour... not as effective. I'm going to go with the bilateral. And then I'll whack the unsharp mask on as well. Yeah, that's not bad. That's not bad at all. Yeah, considering the number of frames, the noise is not too bad. And I can control it. What are we on? If I do this, it will make it a bit lighter. So I'll keep it at 1. If if I just pull this out a bit, if I click on it and pull it out a bit, that usually helps. I can darken the background and hence reduce the noise. And now if I come out to auto, oh sorry, I keep on telling it to go to 100%. Yeah, you see I haven't been observing that much, and I think I told you last time, just use time to just blow the cobwebs out your brain, because you've gone through this process over and over, and if you do it, you know, every week, it's fine, but if there's like 6 weeks between doing it, I start to lose it because I'm old. Let's say we're observed. So let's log it. Do you feel the fact that EA control just crashed there, that there might be a problem? Right, so we're back. So the wind was pretty dire, and it still is. Sorry, excuse me. Yeah, the wind was still pretty dire, and it kind of still is. There's no weather coming in on the radar. So when we started observing, I was seeing gusts of 10 kilometers an hour, and then as soon as I started observing, they went up to 21, 22, 23, 24 kilometers an hour, and the wind got up as well. So obviously realized I was observing and decided, well, let's stop that. So it has settled down. There are definitely longer breaks in it now, as you can tell by the FWHM filter, which is still quite high, because it is. I can hear this constant low level wind going on out there. So even though I haven't put the G shield on, because I thought that would definitely bring the sail area on my telescope up to, it would be too high, it's still being pushed around a bit. So I did a few little tests I was looking at, if you look down here, I was looking at Pandora, Crescimania, and Pavlova, and Thisbe asteroids, and I was just testing out some features in here. So they're the same tools I've shown you before, but I was looking at the difference between Astroplaner and JPL, which we take as the gold standard for the minor body's position. And Astroplaner wasn't too bad. We're talking arc seconds difference between the location that it thought it was at and what obviously JPL was correctly predicted it was, and it was. So JPL was right. So my little crosshairs, which I can show in the deep sky annotation, were dead on with JPL, and it was interesting to see that Astroplaner was only a few arc seconds off. I think if I used the sky, I'd be almost exactly the same as JPL. I've noticed that's kind of dealing in fractions of an arc second difference between them, which is fine. So because it kind of calmed down a bit, I've switched back to something interesting, a Galaxy M110. If I do the DSA on this, actually, you'll see that there's some globular clusters. Actually, I'll just do another it says refined solution found. Oh, okay. So the globular clusters just comes from the catalogue, and as you see, we're slightly off, but there's a globular cluster there. That's B020, bold 20, it's magnitude 14.91. And there's one down in this corner over here, which is 15.5. And if I come out a bit, he says there's some more. In fact, I'll just come all the way out to auto. There we go. So there's loads of globular clusters orbiting M31. This M110 is an elliptical galaxy. I'm not sure if these ones are orbiting around M31, or if any of these are orbiting around M110 as well. I'm not sure. It's an interesting question to find out what the orbit of these guys actually is. And down this side of my screen there's this kind of glow, and of course it is the outer edge of M31. Just little dust lanes you can see forming here, just in this top corner and so on. So there we go, M110. We'll zoom in a bit. Be messing around with SAMP. SAMP uses Aladin. When I say SAMP, Aladin uses SAMP. So it's just a messaging protocol. It's XML RPC calls between them. And there are different profiles. I'm using the standard profile. There's also a web profile, so you can access SAMP on another machine. And that's how, if you go to CDS, I believe that's how it's working when you're, you say to go to Aladin Lite, you know, and it's using, it says, do you want to load this into Aladin? And it uses the web profile effectively to do that. But I'm using the standard profile, which doesn't revolve any warnings, because obviously if someone does try to access something from outside, then obviously your system will, and Aladin will say, do you want to allow that to happen? So yeah, so I just tried a few commands, so I can set the field of view, this field of view for my telescope. There's that. As you notice, it's not orientated correctly, so if I pan it round to how it should be, sometimes if it's better if I just put the RA grid on. There we go. And it's quite interesting. I mean, obviously I can switch between things. I can turn on Sinbad. We can see that the globular clusters that are here are being marked on here as well. I was trying to do? Oh, Gaia. So there's some Gaia stars. If I take Sinbad off, these are references to Gaia stars, or Gaia objects, should I say, and it will go and find, oh, it's a planetary nebula found there. And what's that one? A 2-mass star, magnitude 13.3. So it's quite good. It syncs now. The reason I put it in there was, one is that the images and things like the sky and Starry Night Pro, though I realise the Plus version's more like a Stellarium that has got DSS and HIPS as well, but it just allows you to synchronize between objects that haven't got very good pictures, or we can get a better view. Let me turn off Gaia. Now, where it's an elliptical galaxy, we have got some structure in here. We can see the sort of central star-like nucleus, and we can see that there is this kind of irregular glow, and then we can see the outer glow fading away into the distance. But I thought it was just quite nice to interface using SAMP. And the great thing about that is it means that CDC, which is also a SAMP client, I can also oh, wrong computer. I've got CDC here. I haven't even tried this. Should we bring up Sky Chart? This is the latest beta, is it? 4th of December. Oh, where's it going to put it? Oh, it's going to put it underneath Sky. There it is. So if I go to my tools and I say SAMP Sky Coordinates, there it is. Let's go to 1 degree. So there you go. Yeah, because I hadn't tried that before, but because SkyChart is a SAMP client, and there's a hub, and the hub currently is running in Aladin. There's a few other tools. TopCap, for example, is a tool for dealing with data and so on, and it's got its own hub. It's also got quite interesting. When I was doing it, it was very good to use as a debugging tool because it also tells you all the clients connected to the hub and monitors the messages going to the hub as well. So that was good. I think we're not centered, are we? Center on. And I think I've got a lock on. I can't remember exactly how. There you go. I think I've got a lock onto it, the sky chart. But there we go. So because CDC is a SAMP client, it registered with the hub. And when I say sync with whatever's down here, it will go away and do that. So say I was, I don't know, I wanted to look at M74 again. Then if I say sync, it will go to M74, which is the lovely little spiral, and there you go. So anything that's registered as a SAMP client will get my request because I set a notify all. You can just notify a particular client, and there are SAMP calls to find out what clients are registered at the hub, get their metadata, and so on. So it's a nice little system, and Aladin obviously gives you access to huge numbers of catalogs, but it also has scripting built in, a very simple scripting in terms of accessing the data. It's not the same kind of scripting language like Iron Python or ZoloScript or JavaScript. Slightly different. It's there to more of a data scripting to control and filter different layers, and you can add in data and do and so on to this particular field that you're working on. It's obviously used by research scientists, and I'll do that again because he's moving. There you go. Then it's good, but it's got lots of interesting information obviously on it, and then you can just click on the information. So if I go to here, I believe, I'm told, yeah. So whenever I click, a message is sent from Aladin. It's broadcasting a message. And I believe one of the settings in here, SAMP, is ask for confirmation for jump to coordinates. I could take that off. And then VO tables, let's just do that. Okay. Because then I believe that whenever I click, Aladin is sending this set coordinate point, or point at sky, I think it's called, and to everyone who's listening. And I'm not listening. I'm not a callable client. I haven't registered for, this isn't a callable client. I haven't registered for events yet. Maybe I should do that, but you're not below the horizon, are you? No, you're not. NGC 1342 and NGC 1342. And if I go to SAMP, I can also set my field of view. And if, say, I wanted to add in something else, like the All-Wise colour catalogue, I can send that to it, and that's what All-Wise looks like right there. We can look at the properties of All-Wise. We can see who did it. Oh, Hips creator. Bosch. That was the gentleman I talked to. He was very good. He gave me some help because basically I hadn't bothered to read the manual. A bit embarrassing, but yeah, he gave me some help with SAMP, and it was good really because pointed me in the right direction, and now kind of got a finger handle on how it works, basic handle. So hopefully can use this more. Need to explore Aladin a bit more because it's such a powerful tool to see the filters and so on that I can put in place, and the other bits of tools. It also has a kind of light version where you can put inside a web page and control the user interface, do your own user interface, and then an objects model to control it. That sounds quite interesting as a separate standalone to get rid of some of this. But what I can do with this is I can just go to a simple screen, and that takes up less space. We've been doing this for 10 minutes. It's not the best of nights. I was looking at the limiting magnitude was around 17 point. It was this one. Anna Pavlova was just visible. So 17.2. That was about 30 degrees when I saw about 33. When I saw her. When I saw the asteroid, it was about 33, 34 degrees, I think, above the horizon. Actually, we just check that. We go to my object fields. It was, where's altitude? 31.8, sorry, 31.8 degrees when I was observed it. Let's western sky and see where we are. So we're up here. We're going to target the Blue Snowball.
Telescope slewing 14 degrees.
100 on the T.
Slewing completed.
Well, I don't know about you, but that looks like a blue snowball to me. I don't want to do, let's bring the green down. Let's make it 400%. So now we're at 400%. Let's go a bit further. We've got 800%. So now we can see that donut, and let me adjust that donut. Oh, the wind just got out then. If I bring it down a bit, can you see that donut now? You see that white? It's not really a donut, it's kind of kidney shaped in the middle actually. See the irregular edge. There's a slight lightening at the very edge of this, but that area is slightly lighter. And it's, I say kidney shaped, it could just be two, because that comes in a little bit. No, it's kidney shaped in the middle. I'm on one, aren't I already? So let's just take it out a bit more. Let's just experiment. Yeah, so now we can definitely see this kind of, see now it looks more like a, yeah, kind of a rainbow, you know, a tube going through it. There is a little bit of, this kidney bean shape really. And we can see these areas here. There's might be a little one there, and there. And if we put it back up again, we get rid of it, because now we're looking at the more of the outer stuff. But this is what we're looking at 800%. So we are really pixel peeping, because there is pixel peeping because there are the individual pixels of my image. Let's go back up to 100%. Let's pull it down a bit, otherwise it's getting rid of that structure that we wanted. So that's a total exposure of 2 minutes 42. It's a very bright object, isn't it, the Blue Snowball? Magnitude 8.3. It's on the Herschel list. Oh, well, obviously. Herschel 18.4. I do have a book. I told you it just now, didn't I? There we go, Herschel objects. It's actually better now, isn't it? Mark Bratton's book on Herschel objects. It's very good. I've got a little collection of books now. I'm more of a Kindle person, but yeah. I kind of, for astronomy, for some reason, I wanted the book rather than the Kindle version. And this was second-hand as well, so it was a lot cheaper than buying this book new from Amazon, even on Kindle. It was substantially cheaper, in fact. But yes, good books. I've got a collection of books now. I had Burnham and stuff for years when I was visual student, but and I've got a few other books, but now I've got the catalogues. A couple of Stephen O'Meara's, and Sue French's book is wonderful as well. So 3 minutes 6, and we're still going. Well, it's 5 minutes. And we're at 800%. So, and I'm quite happy with that background as well, that noise, for a hot and cold pixel removal rather than using a dark on an uncooled 294 camera. Let's go all the way out. And let's log it.
Observation NGC 7662 created.
We're up here. There is a comet. Oh, magnitude 7.83. No. Not tonight, I'm afraid. There's NGC 7686. I just can't do Galaxies tonight. I tried M74 and it was all right. I saw a lot more, I see it visually, but I just can't tonight. It's just too windy. It's just too windy. Let's go for NGC. It's an open cluster, quite bright. NGC 7686. It'd be good if my tool was finished, so I could just let's go add that in, please. But I have to type it in. Oh, the first world problems are. Yeah, let's target that then.
Telescope slewing 7 degrees.
Oh, next door. That's interesting. Just a little cluster here.
Slewing completed.
There's the 2 stars. There's an orangey star down here. Let's use some SharpSolve magic and get it hopefully further up the screen now. I really want that star. Go a bit further up actually. Yeah, let's observe that. I just love doing the one click. Having this access thing, just one click, no messing around doing a sequence of things up there and changing this. It's just one click and then we can observe. So we're slightly off. Oh, of course we've gone back to using darks, haven't we? Because we just use a profile. The control, this EA control panel just tells it to use profile 1, and if I'd say profile 1, we're just using the. We're using 2 seconds subs, we're back to 4 seconds now, which might be too much. Let's adjust the colour. It's better, and let's adjust the better. In fact, we'll bring the black level up. Oh, not too far. Let's take it slightly before the peak, and we'll just pull this up by hand for a second just to get those fainter stars coming through. We really want to get that noise out. Look at that noise, lovely. So we've got some noise there. Great thing about stacking, that noise is going to fall away over time. What's our enhancements on? Have we still got bilateral on, I hope? Yeah, bilateral and sharp mask, my go-to favourites. So we've got this cluster in quite a rich area. Let's just DSA it and see what we can see. So that bright star is HIP 115996, magnitude 6.19. I think I turned off my PG Hyperleader catalogue. Hold on a second. Hey, there you go. There's always some galaxies around somewhere. It's a Mira. Oh, that's a Mira star. So this star right here, magnitude 7.49. It thinks, which is 844 light years away, it says it's a Mira. New object. Let's look for V star. Nope. Nope. DL. Andromeda. Aha! VSX134, which is not mentioned because it's got a name. Okay, so we've found it now. So this orange star here, the minor variable, is magnitude 14. Let's bring up the object editor. So it varies between magnitude 14 and magnitude 16.6. So that's this one right here. So we're going to go to an elliptical galaxy. Yeah, we got it.
Telescope slewing 5 degrees.
Oh, really? Next door now.
Slewing completed.
Yeah, there it is, right in the centre. Let's just make it build for us. Actually, no, let's go in and see it, warts and all. A lot of noise around here, but just there, I reckon. Just to confirm, let's. Oh, there you go, 1707, but slightly offset, I think. There we go. Galaxy NGC 1707. It says it's magnitude 15. We say it's magnitude 13.6. Astroplanet says it's magnitude 17. I suppose it depends which catalogue we came from. We got ours from the NGC catalogue, which most probably Robin did. These guys, I don't know if it says revised NGC. And there we go, we have a little galaxy here. We have a PGC up here, which I can just about see, 17.55. Not quite so obvious. There is something there, and there could be something there, but this is fairly. Well, temperature is 12.2 degrees. Outside is now 9.6 degrees. So we're 0.3 of a degree below the lowest we were before it started going up. Should we do our, let's do our 400%, see what we can see. Less obvious. There is something here. There's something, it looks different, especially on this edge. There's a definite edge here, but that could be caused by the, back into 1. Yeah. And this is the advantage of using Aladin over the sky. And so, yeah, that looks about right for us. But there's no picture. Oh, now what I can do is I can download an image. And that's what I get. Oops. It's the original kind of DSS. Black and white images. I'll get rid of it. There you go. Oh, and it also alters this. That's 100%. Let's go back out to the other. Yeah, you can definitely see it. If you come here, there's if you came here, should I say, there's another galaxy right there. Oh, interesting. So there's one up there, one there. And there's another galaxy right on the edge of the screen over here. PGC 71758 by the looks of that. Is it going to give me a... Oh, I've just moved it now. 15.21 all the way over here. I think at 5 minutes we might say, yeah, I'll log it.
Observation NGC 7707 created.
So down here, looks to me like we've got a spiral at 11.1. And that is NGC 7640. What catalogue does it appear in then? Oh, we've got the PGC catalogue. We've got the Herschel catalogue there. Disagrees. I've got the SAC catalogue, which most probably was taken from the PGC. Let's take the PGC one. And let's say goodbye to 7707.
Telescope slewing 4 degrees.
Oh, this looks like a nice one. Look, there's a picture of this one.
Slewing completed.
There's a bright star there. Let's just go into observe and see where this little galaxy is hiding. Right there. There it is. So good just to be able to see it straight away. Yeah, it's right there. What's the Aladin picture looking like? Oh wow, yeah. That's nice. Looks like a barred spiral or something like that. So it's just as a spiral galaxy, it doesn't give any information on it. So it's a galaxy towards a group of galaxies, NGC 7640, so I'm looking at Sinbad right now. Yep, so there's another little galaxy off to one side, and it is there, PGC there, and you can see it just there. So if I now do a yeah, that's not good enough though, so I'll do another, there you go, crosshairs right over the top of it. Magnitude 16.23. Yeah, that's the PGC variation. So there's another galaxy just off the edge of this galaxy. Whether they're involved or whether this is just line of sight, I don't know. So humidity's up to 80% now. Temperature's 9.7. Much to do this. We can see those arms now. That main arm here, the central nucleus of the of the galaxy, and its little friend out to one side here. The only thing to do is just to let this one sit there and cook for a while, I think. So we moved on to NGC 1245. Bit of a problem with the camera, it stopped. It does this now and again. As long as you take the USB lead out, put it back in, then it's all working again for another 3 or 4 hours. Well, 5, 6 hours sometimes, just depends. So we're looking at, as I said, NGC 1245 in Perseus. This is the view in Aladin using the pan-stars. The sky is our current view. We're doing 4 minutes and 8 seconds. The wind's still going up and down a bit. It's quite a nice cluster. It's come out, it's right here. Right, okay, so we're at 5 minutes. So let's just log that.
Observation NGC 1245 created.
NGC 1545, right, okay. Let's add that in. Ask Astro Planner to give us the best one. Let's target it.
Telescope slewing 1 degrees.
Now this is called the Running Man cluster.
Slewing completed.
So these 3 stars here are those 3 stars there. So let's move on up. Yeah, I take it that orange star has got a slight orange tinge to it. This one here is the center point. Okay, NGC 1545 in Perseus open cluster, magnitude 6.2, also known as the Running Man cluster. We'll have to see if we can suss out why. Who knows? Now we've got a little bit of movement going on here. Just going to clear the stack again. The stars were little sausages. We are quite high. What were we? I should say here, 82 degrees. Is that better? Slightly better. Yeah, slightly better. No, more than slightly better. A lot better. It's the time, 3 minutes past midnight. I think we're getting on towards the end now. There was one more cluster down here I noticed, which I thought this one here, NGC 1513, because then we're in the area we kind of done it. Whatever we've done, we've kind of done those 3 together. And this is that was a nebula, wasn't it? That's a planetary. Yeah, I'm thinking these 3 make up this last little observation. We've already done the M&M cluster. We're doing the Running Man cluster, and then we'll do NGC 1513. In fact, let's add it in. Wow. I think we're going to call that. It's a nice little cluster. There's 2 stars. It's a double star there, is it? Yeah. Yeah, we're going to log that.
Observation NGC 1545 created.
Excellent. Let's target the next cluster.
Telescope slewing 2 degrees.
Excuse me. NGC 1513.
Slewing completed.
There it is down there. Our altitude here is 78 degrees. Let's go up. Star here, interesting. Sorry, we'll look at that in a second. Let me observe NGC 1513. In the sky, this orange star here is that star there. Yeah, I just wondered if it was a variable star, but it doesn't appear to be. Interesting that even though it knows it's in Sinbad, it's marked it as Sinbad, when I try and do a search here, it doesn't do it. But I can just say, oh, wherever the reticule is, then copy it, and then I can go into CDS and grab it. But that's a bit interesting. I don't know why it does that. I'm not doing so well now. I can hear the wind blowing outside quite a lot. 12 frames stacked, and plus it's midnight, so it's way past my bedtime nearly. To be fair, we've done quite a few objects. How many objects have we done tonight? 18 objects, 15 observed. Well, it would be 16 observed. And VSX we did observe, that's 17. So where was the other one we didn't observe then? Let's look at the stats. November was good. October wasn't so good. Let's look at the constellation. Cygnus was it's the constellation we spent most time in, then Cassiopeia, other, but Vulpecula. Oh, that's most probably when I was looking for the variable star, so I was going back to that all the time. Hercules, all the way around. It's good, isn't it? It's quite a nice layout. This is only showing the observations that have been made since So I have other observations in other databases, but where this is beta, and I like using the beta, I sometimes start from scratch again. I'm not sure when I started this database. Let's log this down. 7th of July. So in July I started this database. So I have other databases, and when Paul releases it, my intention was to go back and grab the observations out of the other databases which I have backups of, and go from there. That was the idea. I'm 100% sure I do it, but it's just interesting to see that in the summertime, I've been working my way from July, most probably this way through, and now we're coming into obviously in winter, so now we're starting to come along here, and then we're going to spring, and then we go all the way around, which is good. So what's our observations tonight? There we go. Displayed 17 observations from one session for 16 objects. That's correct. That doesn't sound correct. I don't understand why. That's one more than it should be. Yeah. It is good. Astroplan is good. And I see Paul said in the forum that he's hoping to get it out soon, but we've got to stop finding bugs. Or making feature requests, which, yeah, I shouldn't really, but Paul really supports the product really well, you see, Astroplanner, and it's just, you should really just say no, but it's all good stuff. And it does mean that because of what Paul's work did here, you guys can integrate with Aladin and any SAMP client as well, such as Cdc Ciel. Oh dear, just butchered some more French. Cdc. I can't. No. 2 minutes 52, 43, but we've dropped quite a few, 37 frames. We have moments when, during the observation session we'll be doing this evening, that we've had this calm settle over us, but then the wind comes back with a vengeance, and we end up losing half our frames. Excuse me. as I said, I think if you were doing astrophotography, you would have given up. I also think you most probably would have given up if you're doing visual astronomy, because your telescope would be vibrating all over the place. And at least with this, the stacking stabilizes the image, and we can cut out quite a lot of the big buffets of wind. So another +1 for electronic assisted astronomy over visual and over astrophotography. But that's more about a quality thing than I think with visual you just get sick of having to watch the stars go woof and then this telescope settle again, and where you can't remember what you're seeing is what you're seeing. With this, we're building up the image as we go. EAA, the future, and the current. So in January I've been doing this 4 years. Can't really believe that I sat out for decades under the night sky, freezing to death or being bitten to pieces by gnats and things, little bugs, seeing nothing compared to what I can see now in the last 4 years. There you go. Okay, let's log that.
Observation NGC 1513 created.
Excellent. Let's look at the western sky, and we're miles up, weren't we? We were up here. There we are. So Pegasus and Andromeda are sinking now to the west. There's Cygnus still. Let's go over to the southern sky. We've got Orion. Leo. Behind Leo, Virgo. A reminder that soon galaxies galore will be here. So anyway, yeah, there we go. Another session of electronic assisted astronomy. Very windy. As I said, I don't think you'd sit out there if it was a visual astronomer, and you'd be having to stop every few seconds to let the telescope settle while you observed. An astrophotographer wouldn't do it either, because you wouldn't get the quality of shots you needed, because you'd throw away your subs. But with 4-second subs, we've managed to look at, was it 17, 18 objects during the course of the evening. So it's the advantage of electronic assisted astronomy. Well, thank you for joining, and maybe we'll do it again when it's better conditions. Yeah, that would be nice. Anyway, bye-bye.